In this video, I'm going to cover the concept of drawing Lewis structures or Lewis diagrams for ions. So to do that, I will show you a series of steps that you need to follow. This applies to every Lewis structure, so it doesn't need to be necessarily for ions, but one step of it is particularly for ions. So as you can see, the first step is to count the total number of valence electrons. So you add them up. And then if there is any charge, you have to adjust the charge based on that. So if there is a charge of negative, that means there's additional electrons. So you add those electrons to the valence electrons. If the charge is positive, that means there's electrons lost. So you have to subtract electrons from it. Then third step is to draw single bonds between the central atom and the surrounding. And then you complete the octet, but first by putting it on the outside atoms first. So don't worry about the central atom for now. Just focus on the outside atoms first to make sure they have a full octet. So this is the step that I was mentioning that is particularly for ions. So this is a step that it's going to be a little bit different if you're doing the Lewis structures, if there's a charge to it versus when it's not. Then step 5 is to place any remaining electrons on the central atom after you're doing the electron counting. Then you check for the octet for atoms. So most atom needs to have 8, but there's some exceptions. For example, hydrogen is happy with 2 or boron is happy with 6. I have another video that I cover the exceptions for octet rule. If you need to take a look at that, I'll tag it over here for you. And then at last, when you do the check, and if you see the atoms are not happy and satisfied with the full octet, that's when you start making double bonds and triple bonds. So I'll show you examples right now how that works. So the first example is NH4+. So first thing is, as we said, we have to count all the valence electrons. N is in group 5, so it has 5. Hydrogen is group 1, so it has 1. And then there's 4 of them. So it's 5 plus 4 times 1. But then because the charge is plus 1, that means there's an electron removed from this atom. So we have to subtract 1 electron from it. So our drawing in total will have only 8 electrons. Next step was to put the central atom and then connect 4 single bonds to the outside atom. So you put N in the center, 4 single bonds, and then you count how many electrons you use so far. So each bond is equal to 2 electrons or a pair of electrons. So in total now we've used 8 electrons in this drawing. So when I do the counting, I see there's no electrons left at this moment. And then this takes us to step 6, which is very important, which is the check step. So this is where you have to decide if you have to make double bonds or triple bonds. Otherwise, everything has a single bond. So the check tells us which atoms have the full octet and are happy with their structure after the bonding and which atoms are not. So if we take a look at over here, we can see that all the hydrogens, they have 2 electrons because they are an exception. They're happy with 2. So all of them are good. And then taking a look at N, same thing. N after bonding now has 8 electrons. So it has a full octet, happy. So the structure looks really good. So we do not need to go to step 7 right now. And then every time your compound or it's in the form of an ion, like in this case, NH4+, after finishing the Lewis structure, you have to open a bracket, put it inside a bracket and put the charge on the outside. So we're good with this structure. Now let's take a look at another structure, something like Cn- cyanide. So first thing, we count the valence electrons. Carbon group 4 has 4, nitrogen group 5 has 5 valence. And then because the charge is -1, that means we have an additional electron. So the total number of electrons is 10. Then we do a single bond between them. We subtract 2 electrons from it because we used 2 electrons already. So we're left with 8 electrons. Then we have to put the electrons on the outside atoms first. So both of them are on the outside, so it doesn't matter which one you start with. My suggestion is fill up one, make sure one of them has 8 electrons around it after bonding before you move on to the next one. So I'll start with nitrogen first, for example. So I put 2, 4, 6 on nitrogen. I still have 2 more. I put the extra 2 on carbon. Now all my 8 electrons are used, so we have no electrons left. So this is again where we have to do the check, step 6. We have to check to see everything has the full octet, or if there are exceptions, we're okay with that. So we take a look here. So in this case, nitrogen has 8 after bonding, so it's good, but carbon has only 4 electrons, so it's not good. And that is the step that you actually have to move on to step 7 right now. So now because carbon is not happy and we're out of electrons, so I cannot randomly add extra electrons. So I have to take some electrons away from nitrogen and share it with carbon. So we go to step 7 for that. So here, what I'm doing is I'm taking a pair of electrons from nitrogen. I'm adding an additional bond between carbon and nitrogen. And then I check for carbon again. Now it has only 6 electrons, still needs 2 more. So I have to grab another 2 from nitrogen and then make it shared between the 2 of them again. So this way your electron count is not changing. So you're still using 10 electrons in total in your drawing. So everything is good. But then if you do the check right now, you see that nitrogen is good. It has 8 electrons still. And carbon is good too, because it has 8 electrons after bonding as well. So our structure looks good. And again, it's a charged ion. That's why we have to put it inside a bracket, and we have to put the overall charge on the outside. One more example, CO₃² minus. So we do the counting of the valence electrons, 4 for carbon, 6 for each oxygen, so times 3. And then the overall charge is 2 minus, meaning there's 2 additional electrons, so 24 electrons in total. Then we put the central atom. We connect it with 3 single bonds to the outside atoms. So far we're using 6 electrons. We subtract 6. So we have 18 electrons left. Then next step was to make sure the outside atoms have a full octet. So we put the lone pairs on the outside oxygens, not on the carbon yet. So 2, 4, 6 here, another 6 here, 12, another 6 here, 18. So this way I'm using all my 18 electrons. So no more electrons for central atom. Now again, this is where we have to do step 6, which is very important, the check step to make sure everything is happy. Oxygen is good. This oxygen is good. The bottom oxygen is good. But if you look at carbon, it has only 6 electrons right now. It doesn't have 8. And we said everything needs to have 8. Most atoms need to have 8 electrons after bonding. And that's why we have to move on to step 7 right now. So we have to take a lone pair from one of the outside oxygens and share it between carbon and oxygen. So what we do is we take this lone pair, let's say, out, and we make a double bond between carbon and oxygen. So this way my electron count is not changing. But if I do the check, I see oxygen is good. The other oxygen is good. The bottom oxygen is good. And the carbon is good. So they all are good. So my structure is happy and good and stable. So now I can put it in a bracket and put the overall charge on the outside. Yeah, so that was a very simple video. I hope you enjoyed it. If you liked it, please make sure to hit the like button and follow up for more. I'll be posting more videos shortly. Thank you.